Well, I guess we got a crowd here. Let's get after it. So, connecting phones and slates to Windows Azure. I'm just going to say that this title will probably be a giant understatement. You know, there's plenty of sessions that can tell you how to connect that, and lots of people think they know the secret sauce of the way to connect it. There's obviously a number of ways to skin that cat. This session is going to go way, way beyond that. I've been doing sessions on connecting Windows Phone to Azure for about a year and a half, and I don't want to give you the same old, hey, let's call a web service and talk to SQL Azure and get some data back. I know you guys have seen that ad nauseum, so we're not going to go there. So anyway, I'm Rob Tiffany. Oh, wait, I can't talk yet. You might get a phone. Wow, stop the press. There's an actual reason beyond me or listening to music to stay here. You could get a phone. So, like any of the phone sessions you may have been to, I will ask a trivia question, and it will be something that I talk about during the session, so you have to pay attention. And if you can answer the question, then I'll give you a coupon, which I don't see the coupons up here, so hopefully some magic person's going to come in here during the session and give it to me, or we'll figure it out. But there's a booth, and Expansys has a booth kind of in the back of the exhibition hall near the Windows Phone booth. And anyway, the Windows Phone booth, yeah. When's the last time I've seen a phone booth? Anyway, where you can get a phone, and you actually get your pick, you know, because I know everybody's with different mobile operators and stuff like that. So that's all good. So there you go. Oh, there we go. Now I can say, I'm Rob Tiffany, and I'm an architect at Microsoft, and I work in a little group that kind of straddles two groups at Microsoft. It's called the Mobility Center of Excellence, and so we're partly in the Windows Phone group, and we're partly in worldwide services. So customer-facing means we like to spend time with folks like you and fly around the world talking to lots of our global customers and helping them with their mobile issues and wireless and big architectures and you know, rolling out infrastructures and app dev stuff. And so we've been doing this mobile stuff now for the last decade, and it just keeps getting more fun. Obviously, we did a big reboot of our whole phone thing last November, and so it's pretty exciting stuff. Anyway, and I like to write, and I'm not going to plug any of my books because I haven't written any new computer books lately, but I did just finish a children's novel, so that's kind of different. Probably won't go over well here. Anyway, so let's talk about this session here. Did anybody come to my session on Monday? One person? Two people? Excellent, thank you. That was a kind of a chalk talk with no slides, and as I told them, and I'm going to tell you now, just to make sure to set expectations, I'm going to talk about a lot of different things, but more than talking, I'm going to do a lot more showing. And that showing is going to be lots of code. I think I've got 2 or 3 instances of Visual Studio running here, and Azure emulators and device emulators. And we're going to look at a lot of code. And we're going to walk through a lot of code. So we're going to hit the F10 key a bunch of times, and maybe we'll hit F11 every once in a while. And so, and we might even look at tooltips to see what things are happening there. And so I just want to make sure before I go there that you are in the right room, that you care about stuff like that you want to see that, because if you don't, I certainly don't want to waste your time, because that's the kind of session it'll be. So we'll talk about a lot of stuff. I'm going to show you we're going to just go super, super deep on making some really cool stuff happen. So that's the gist of it. So if you're okay with that, then that's good. So I'm going to start off just kind of giving you a level set of how I view the world of mobile and wireless. Just so you can see where my point of view is, and that will lead to kind of the things I talk about in this session. And I combine that state of where I see wireless today, because and you'll see I always have a heavy emphasis on wireless. I know lots of people like to talk about mobile in a vacuum, but I don't think you can do that. I think they are hand in hand. There's not one without the other. So then how that works with scalability and performance. And I'm going to talk about things that you probably use every day and talk about examples of some of the most extremely scalable and performant systems in the world today, and talk about why they are that way, and then how you might be able to recreate some of that scalability for your own systems. Then I'm going to do a quick intro to a scenario I've been in other sessions where people from Microsoft goes, we can't talk about it if we don't have a scenario. So I'll have a silly little travel scenario that I invented, and I won't spend too much time on that, but at least it'll give context. And the key thing here, I'm gonna mostly spend time, all the code and everything I'm gonna show you is all in Phone 7. But I will show you a Slate version of the same app. And one of the key takeaways here is, and you might have gone by the Windows Slate booth, and we are moving ahead with that. We're seeing a whole bunch of new Slate devices, tablet devices coming out with Windows 7, taking advantage of multi-touch and everything. And so that's going to just keep accelerating and accelerating, and I think we all know why, because there's an elephant in the room that's kind of helping to push everybody in that direction. And so I want to make sure it's all mobile, and it's all connected to the cloud by wireless or to your own on-premise data center. And so I don't want to just lock you into, he only showed me how to build phone stuff. The stuff I'm going to show you works on Windows, phones, wherever. Anything where .NET lives, basically, is the kind of stuff I'm showing you. And then the key thing here, as I said before, looking at all this stuff. We're going to look at two halves of stuff, and it's just going to be a lot of stepping through code and talking about it. I don't have a whiteboard, but I got some really pretty pictures to show you, and that's really important. So the Azure side, and how we build this, how I'm going to build this really scalable infrastructure using SQL Azure worker roles. I basically just tried to use almost everything. Now, I wasn't doing that just for the sake of using everything that Azure provides. They all have a real purpose in making a system scalable. And then on the flip side, when we get on the client, whether it's phone or Slate, any .NET endpoint, basically. I'll talk about consuming services, talk about how to create your own database. Of course, maybe some of you have gone to, Sean McKenna did a session yesterday on new structured storage. Basically, SQL CE is back. If you've known me for a while, obviously I spent a lot of time in the last decade working with SQL CE and Sync and stuff like that. And so that's exciting that it's back. I'm not going to talk about SQL CE. I'm going to talk about something that I had already had going before we brought that back in Mango. But the stuff I'm going to show you as far as being able to roll your own, really simple kind of a in-memory database. It'll work on any .NET platform, and it might meet your needs. If now if you need more complicated SQL capabilities, then yeah, SQL CE would be a better choice. And then we're going to really do a stretch here. And I've just started rolling my own change tracking, because being a sync guy, I know how important that is. And so I'll show you how to do change tracking on a NoSQL table-by-table basis in your own stuff. So there's nothing worse than reading from your slide, but I've got to read from the slide of the very first deal. So everybody knows about the big merger going on with T-Mobile and AT&T. And AT&T is given a lot of reasons why they need to do this. But most of it has to do with bandwidth and congestion and needing more of it, needing more cell towers. We are going to deliver as much data on our network in the first 5 weeks of 2015 as we did all year in 2010. That's just crazy. The big message here, the big takeaway, I've got this list of congestion factors, but even as we move technologically and are coming up with better and faster technologies, lots of people just sit around and go, well, we got 3G and 3G plus, or maybe I've got 4G, or some operators are trying to call their 3G stuff 4G, things like that. And they think that's going to make it all better and that we'll be able to have this unlimited bandwidth and moving around. The reality is it's just nothing can be further from the truth. The technology is there. It actually does work, but it's competing with something. And it's competing with all these extra subscribers. Just kind of here on this congestion factor. People are all, using more data than ever before. So much data now that many mobile operators are now really kind of trying to put caps on things across the board and limiting how much data you can use, because a lot of the unlimited all-you-can-eat plans really started to hammer some of these mobile operators. And so they're reeling from this. And no question, it really exploded big time with the iPhone. No question about it. Our phones, all the Android phones, it's an explosion. So if you don't believe that the world's moving just all wireless, it is. It's all around us. And so, I think we're definitely moving in this direction of mobile devices connected to the cloud, via wireless. And so, but all these things are working against you. So extra people uploading photos, watching videos, doing Ustream. I could be Ustreaming this right now. Wouldn't that have been fun? And things like that, watching movies, watching Netflix on your phone. All those things, you're having to battle against it. And so, the cell towers, that's the other thing. AT&T, they're going to get a bunch of T-Mobile cell towers. That's stuff they would have had to build themselves to get more cell tower density. When you talk about wireless spectrum, there's different frequencies. And, if you're a wireless geek, you know what those frequencies means. Some of the higher ones, it means they don't go as far. The bandwidth, they won't fly as far through the air. And so and they don't have as much in-building penetration. So they have to build more towers to get there compared to lower frequencies. So when we did the big 700 megahertz sale, auction, that was a big deal because 700 megahertz is nice and low. And so that will travel farther and go into buildings deeper. And so that's good stuff. So anyway, these are all things to work with. You got to care, though. You cannot, as a developer, be lazy and just say, well, I'm going to build whatever I'm going to build, and I'm just going to rely on the network to work, because that's not my problem. It is 100% your problem. You have to care about this stuff. I talk to people, a lot of people, the term UX, user experience. Some people kind of blend it with user interface and things like that. But user experience, people often think it's all about the UI and how cool and how great a user experience is. Well, I'm here to tell you, the user experience goes all the way back to this network. It goes all the way back to when someone clicks a button and it goes up to that cell tower request with about 1,200 of their best friends all trying to clog in there. Then it goes down to the base station. Then it goes into the backhaul network, which may or may not be sufficient to accommodate all the cell towers. Then finally gets out on the internet, finally gets to your destination, goes through a firewall, maybe a reverse proxy, hits a server, maybe is caching, finally gives you a response, and then goes back through all those hoops again to get back to your device. All that is user experience too. And you can see that a whole lot of things just happen to make a simple web service call, let's say. You need to think about how can I make that path as fast and efficient as possible, so that, because people like speed, and people don't care about your excuses, oh, well, the network sucks or whatever. So I'm going to talk to you about wireless efficient web services. And I've talked about this before, and I'm going to combine that with some other things. So now let's talk about scale and performance. I'll cover efficient ways to do web services to be efficient over networks. But remember the part that you get to the end after you've jumped through all the hoops, you get to that infrastructure, the servers, the web servers, the whatever you're building, that has got to rock. It's got to be fast and it's got to be scalable. And I'm not talking about the scalable that we've been doing for years where you are able to support thousands or tens of thousands of people in your enterprise. If you want to start thinking about the next level of scale, I've got some examples of some big names over here. Our search engine being Facebook, Twitter, Zynga, Foursquare, Google. Why do I have those things up there? It's because they have had to tackle a new level of scale, a consumer level of scale that is unprecedented in the history of the internet or anything anybody's had to build before. And they used a lot of trial and error over the last decade or so, but by hook or by crook, they have come to find some things that work for them. So, I will probably zoom in mostly just on Facebook as an example, and I'm going to give you this kind of example of what they're doing, which is similar to a lot of these other guys, and then I'm going to relay that to how could you do something that's similar, use some of the same principles in building your own infrastructure. Not all of it. I don't expect you to be able to just go be Mark Zuckerberg tomorrow. But I want to show you some of the key elements that you could do yourself so that you could start going from building systems that are, maybe fast enough and maybe can scale to 100,000 people so you can just infinitely scale out to millions of people. And that doesn't mean, go to the cloud, go to Azure, and I can just keep cranking up instances and adding new servers. It's not just brute force about that. There's more subtlety than that. So let's go down the list here. A database that nobody touches. What in the world does that mean? So for years, we built client-server stuff where a bunch of clients, maybe you could get up to a few hundred, would connect directly to a database, to SQL Server, to Oracle, whatever. And that goes so far and runs out of gas. Then we went to multi-tier, and we went to connection pooling, and we were able to get more and more people connected to a database at the same time. Then we started doing things like replicating. We started being able to, we said, well, let's get load balanced web servers and have that going against the database. And that got us a little bit further. Then we started doing things like maybe having a master database that would have replicated other databases beneath it that had copies. And we would load balance those and load balance web servers so that you were load balanced two ways and could do horizontal scaling. That's great stuff. And it gets us even further. But guess what? Even that's not far enough. Facebook spent a lot of time. I think they made it out to, and I might be wrong here, I think they went as far as maybe 1,600 MySQL databases at one point to support their infrastructure. But you know what? At some point, that still ran out of gas. It just ran out of gas. And they didn't like the unpredictable I/O they got. So what they ended up going to is, which I kind of go down here to this third bullet. Has anybody heard the term NoSQL before? All right. Well, you're going to be hearing it more and more and more. And you're going to be seeing scenarios where that makes sense versus using a relational database. And I'm not going to have a discussion of SQL Server versus Oracle here. I'm going to just kind of abstract it to a higher level than that. So what you see Facebook and a lot of other folks going to is these NoSQL databases, or it's better to call them just tables. Just think of just tables that are sitting on commodity hardware. So like Facebook, I think, has maybe 30,000, commodity servers. And they're all designed to fail. They don't want them to fail, but they know they're going to fail. And so they build the software to fail. And so that the system can keep going, even as servers all over are probably failing every day, right? And somehow you and 600 million of your best friends are loading your Facebook page, and it comes up fast. Well, how does that happen? Well, it doesn't happen by you clicking your Facebook page and it queries MySQL to get all that answers. It would never work in a billion years. It happens because of all these thousands of these little NoSQL tables of data, of different, you've got to partition your data to just be able to break it apart as far as possible, or you'll never be able to scale. So what does that mean? If you're a database person, you might say, well, Rob, what about ACID support and all that kind of stuff? Well, if you need ACID support, like if you're building a banking app and you need quick, like you got to confirm a transaction, this stuff won't be for you. But for a whole lot of other scenarios, this might work for you. And you often hear, the part that falls down in ACID with NoSQL tables is consistency. They're not all catching up to each other. And you hear the term, they'll be eventually consistent. So that works for a lot of scenarios, and it certainly works for these guys. I'm going to show you how it's going to work for you as well. And so imagine if you had a database with 100 different tables of different kinds. The real quick and dirty part is I'm going to take each of those tables, if I can break them apart, and I don't need to do hard joins against them all, I'm going to put each one of those into its individual kind of NoSQL table, And that might get you some scalability. But you can go further than that. You can do something called sharding. And so this is what a lot of the folks are doing with NoSQL tables is they shard the data. So a simple example, and it's a bad example, but like you might have a customer table with millions of customers. If the tables alone and breaking apart is not enough, they can't ever get too big. Because if you're doing a query against something that has hundreds of millions of rows in it, that query, just because of the laws of physics, is going to take longer than if the table only had a few million rows in it. So an example is you shard that data across. Some customers, and here's the bad example, some customers' last name A through F are in this shard, and F through M are in this one. Things like that, breaking it out. That's a bad example with the alphabet. Some people do it by size. Some people do it by how much RAM they can do on the nodes. So anyway, break it out as far as you can. You're load balancing everywhere. You're load balancing your web servers, obviously. If you've got application servers, and what we'll talk about is kind of worker roles in Azure that are doing things, having those load balanced and broken apart, everything's load balanced at every level. And then the other key thing beyond the scale out is even that's not enough, because disks are the enemy, right? So ridiculous levels of caching is the other part to make sure that things come back just fast, instantaneously. So a real popular thing that Facebook and some of the other folks use, it's an open source thing called Memcache. And so it might surprise you to find out that Facebook has 300 terabytes of data in Memcache RAM all distributed across their servers right now to make things fast. Caching is part of the equation. You've got to cache and so caching is not just about the obvious speed, but remember, there's a relationship between speed and scalability. If I have to get some data and it's already in RAM, I didn't have to touch the disk, and I get in and get out my request faster, which means everyone else who's waiting in line can then get in sooner, and then that adds to more people being able to get in. So you get more scalability out of that. Some of the other things is the kind of code you use when you're building these giant web-type things. Luckily we've got .NET that compiles to native code. The Facebook folks, they love PHP. They think it's really productive, but it was too slow. So they had some folks build this thing called hip-hop that compiles PHP to C++ code after they build it, because they knew that they weren't going to get what they needed from a scripting server language. But they wanted the best of both worlds. The last thing, and I'm not going to show you how to do this, something called MapReduce, which is something Google came up with. Well, MapReduce is kind of a thing you see in functional programming languages, but to work with just massive sets of data that you just can't even imagine how big it is. And Google did that when they invented Bigtable, which is kind of their NoSQL thing, and they used MapReduce to pull all these queries and things together. And then there's an open source version of that called Hadoop. That's through the Apache group, and so you see some people using that. We have something at Microsoft called Dryad, which encompasses our MapReduce, and we use that with Bing and some other things. So how do we map this to what you could do in Azure? Because I want you to be able to build something that can scale to millions of devices if you need to. You may never find yourself having to do that, but you know what? If you can even get a glimmer or just remotely close to that, you'll probably be in great shape with the kind of things you do at your employer or for your customers today. So we know with Azure, you can create as many instances. You got web roles and worker roles. So the web roles are either your web pages, if you're building a website, or web services. And I'm going to focus in this session just on web services. But either way, so being able to scale out, be able to be elastic, and add as many as you need. If there's a spike in demand or pullback, you only pay for what you need, that kind of thing. Then the other thing is I'm not going to have you in a scenario where you're going to have 1 million people all hitting those web services, and then they're all trying to call SQL Azure to get an answer back. I don't want you to do that, at least in this scenario. We're going to have some other things to talk about in SQL Azure in the future. But right now, what I want to talk about is, since this is going to be about mobile and pulling stuff down, it's almost kind of like sync, we're going to be able to have that kind of optimistic concurrency. And so you're going to be pulling tables down to your device through this session. So what I'm going to have is no device will ever touch SQL Azure. What's really going to happen, and I'm going to walk through, is you're going to have worker roles in the background, and it's their job to pull over individual tables from SQL Azure into Azure tables. Because lo and behold, we've got a NoSQL solution at Microsoft, and it's called Azure Table Storage. And it means key-valued pair, no schema, it's schema-free, it's like a collection of objects. Each row could have a different number of columns. But it's very fast, ridiculously fast access. And of course, we give you all that great redundancy. We replicate 3 copies of everything, everywhere. So you get that redundancy, and then you can also do something to scale those out too. There's different, if you want to think of them as columns, even though the paradigm is totally different in NoSQL stuff. But you have a thing called a partition key, kind of a row key, and then maybe the stuff you care about, a username, whatever, an address. Partition keys can be used, and if a NoSQL table from Azure all has the same partition key, it'll all be on the same server. But if you start changing those, let's say we had an Azure table for shirts that you're selling. Maybe you could have a bunch that say blue shirts with all this other information of other columns, and then red shirts and whatever. Azure will automatically recognize that, and it will put blue shirt tables on other servers and red shirt tables on other servers. And so you'll start to get this fanning out. And then the great thing about this is you don't have all these devices all doing I/O against one database. You have massive parallel I/O going across lots of servers at the same time. And that's where you're going to get this great scalability. And so that's what I want to show you how to do. So worker role is going to push stuff out there. So when devices call your WCF service, in this session at least, I'm going to show you how to call those Azure tables instead of calling SQL Azure. And it's pretty cool. And there's a couple ways to do it. I'm going to show you a way to do it that uses LINQ. It's kind of fun. And that's how you're going to get data down to the device. I'm going to walk through some cool stuff on the device, on Phone 7, but it also would work on a Windows Slate as well. With some offline, I built my own NoSQL database that you can use on your device. But again, we also have SQL CE, so just depending on what's appropriate. And then when you have devices and they need to push data back up to the server. So, I made some changes. I captured some data. I'm doing anything that needs to do an insert, update, or delete. Again, you're not going to have a million devices trying to do inserts, updates, and deletes against SQL Azure. You're going to call into those web services. Those web services are going to catch that data, and they're going to immediately drop it into queues. You need to be loosely coupled. You need to build a fortress around SQL Azure. So call, drop in a queue, and gone. And so, again, you'll never have that high level of contention against your main database. Then the last part is a worker role. It'll be a worker role's job to pull stuff out of the queue in an orderly fashion and do those inserts and stuff into SQL Azure. I mentioned earlier caching. We have a caching that works a lot like Memcache, and we just released it. It's called App Fabric Caching. We had a project called the Velocity Project that's been working for a while now on on-premise Windows servers that you can get. And so it's finally come out of CTP level, and it's available now. Name value pair kind of caching you do yourself. I'm not going to show that to you because we just released it, and so I don't have all the code working. But I am going to show you something that you can also, another type of caching that you can use. I'm going to show you how to build it into your WCF services. Has anyone ever worked with ASP.NET output caching before? Well, you can make that stuff work with these REST services I'm going to show you. And so until you get up and running with App Fabric Caching, you can use output caching for things when you're just doing lots of selects and pulling data. And you know that there's a lot of common data that get pulled over time. And I'll show you how to get that wired up. And so that's a real quick and easy way to get some good caching going really quick. Then I talked about we're going to do efficient wireless web services. I'm hardcore on that. I butt heads with people all the time. There's a lot of ways to skin a cat if I need to return a list of data. If you've been to sessions I've done before where I show you pulling down a list of 8 delivery drivers, and if I do it with OData, it's like 8K. If I do it with SOAP and data sets, it takes it down to 3K. If I switch to REST and XML, it drops you down to 1.2K. But then if I switch to REST and JSON, it takes the same data down to 600 bytes. That's where my point of view is. That's where I come from, and that's what I care about, because I care about the stuff I talked about earlier: wireless congestion, user experience, and speed. So I want you to always be thinking, how can I go the extra mile for my customer, for my company, to build wireless efficient stuff? It's going to be faster. It's going to save them money if you have capped data limits where you can't blow out and go all you can eat. You can only do so much. This is going to help you. And if you start doing stuff with Azure, we charge you inbound and outbound data access, bandwidth coming in and out of the cloud. Well, guess what? I'm going to go the cheap way and use REST and JSON, so it doesn't cost me as much money to go in and out versus a larger wire protocol. Okay, here's the great scenario. I've spent a lot of time working with customers, and I've worked with the railway system in France to help them design their whole railway system, and I do a lot of stuff with transportation. So here's my silly scenario. Think of it as like a ferry system. So up in the Seattle area, we got Puget Sound, we have ferries going everywhere. I used to drive submarines a long time ago. I thought it'd be cool. What if we had a submarine service instead of ferries? And people would pay, and maybe it's for really wealthy folks that live on this little Bainbridge Island place, and they need to work downtown, and they need to get there fast. And so my scenario would be something like, you'll make reservations to ride these little tiny submarines that hold 8 people, and then a limo will pick you up and take you to your office. And so the simple scenario is, it's beyond just a ferry system. I'm going to let you, kind of like an airline, you need to be able to pick your seats, and see when schedules are and stuff like that. And so that's kind of the scenario I followed in building. I haven't built out the whole solution, but that's kind of in the background when you see the code I'm going through, is to do things like that. And I'm not going to show a lot of data. I want to keep it simple to just get the concepts across. So I'll be working with just a simple list of submarines. But you can imagine when the full scenario is built out, devices will be pulling down schedules, reservation times, all the users who fill in their information, about their making reservations, updates, doing direct push type stuff, our notifications like we have to devices to tell you, oh, your submarine's late, things like that. So kind of like an airline, kind of like a ferry, kind of like a train, because we'll definitely have conductors on these submarines. All right. So let's dive into the fun stuff. Let's geek out. We have this big Mondo architecture. Now, I started out, I had this giant picture that showed everything I ever wanted to talk about on one screen, but a good friend of mine, Augusto, said, yeah, I think people will just be overwhelmed. Let's just slowly build this thing bit by bit. So I've kind of talked through what's going to happen here. And so what I'm going to do, and up at the top, it may not make sense to you up what's in the middle there, but it's a progress bar, basically. And we're just going to walk through the progress bar until we're finished building the architecture. And this is going to help me guide you through this. We're going to talk about the picture. I'm going to jump over to some code, show you how to work on the code that just fills out that picture, and then we'll move on to the next bit, and so it'll all keep us on track. And and as I told the folks who came and saw me on Monday, I always like to keep my little 3x5 cards to make sure I don't gloss over anything, because there's a whole lot of code and a lot of moving parts here, and I don't want to skip anything. So the first step we want to do here is, as I kind of talked about, no device, none of our millions of devices are ever going to talk to SQL Azure directly. So we're going to protect it. So we're going to have a worker role, and that's something you can, when you go in Azure and you do the wizard, you can build web roles, worker roles. Anyway, worker roles running on a separate instance, a separate VM than your web role, so different machine, and you can make it different size machine and with RAM and CPUs and have as many instances as you want to scale out. So this worker role, think of it, everybody built NT services in the past. That's what a worker role is. Think of it as just your NT service running there in memory doing stuff in the background. So that worker role, it's got a simple job. All it's got to do is pull stuff from SQL Azure. So in this case, you can imagine maybe there's hundreds of tables in this database, which I don't have yet. But it's going to pull stuff over, and it's going to populate Azure tables with that. So just one for one. So we're going to keep it really simple. It could filter those and populate the tables with different shards of data, if you want to scale it even further. The other key thing is, I do a lot of, there's this kind of a whole, I work with Gartner on this whole thing. It's called Mobile Enterprise Application Platform, this MEAP thing. And there's this kind of MEAP architecture where you have different backends feeding data. And depending on the data, some data will be updated all the time. So the worker role will discriminate between, it's not just blindly blasting new data into these Azure tables. So lots of time you have reference data, lookup data, maybe it doesn't change very often. And so maybe a worker role, maybe once a day it updates a table, maybe once a quarter, it just depends. Other things needs to be more frequently. So that's how you can kind of think of it. So the first thing I'll do is we're going to walk through and show you that. So let's jump over here to code land. All right. So we got our submarine service. And while I'm going to be showing you mostly all the phone stuff, I might as well show you too. This would be a Slate version of the same app that I'm going to show you running on Phone 7. As we move to kind of the Slate, kind of an immersive, all-encompassing, full-screen apps, you can imagine things like that. Schedules, being able to make reservations, to travel, pick your seat, stuff like that. So this would kind of be your Slate version of the same thing, but we're going to focus just on the Phone 7 version of it. So, but anyway, the code's very similar. Just because it's Silverlight, under the covers, it's just the same .NET, the same C# or VB, whatever you're into. So let's start at the very beginning. SQL Azure. Luckily, you get to use your normal SQL Server Management Studio and SQL Server Express when you set up stuff with Visual Studio. And I'm sorry that everything on here is so microscopic. But as I said, we're going to keep it just super simple. So all we're going to focus on is this tiny little list of submarines. And there's a submarine table in a submarine DB database. And it's really a lookup table, but I'm going to use it for demonstration purposes. And I'll add and remove submarines from it. And you'll see how it kind of goes around and does it. So right now, we got two submarines, the Seawolf and the Nautilus in there. So this is where we're starting. And so we know from our big picture, for our demo, that the first thing we need to do is we need to pull those submarines over into an Azure table. So let's do that. So let's look in Visual Studio in our Azure Submarine service. So for starters, I'm going to uncomment. So this is my worker role. I'm going to uncomment this code. And at different times as I'm going through, I will comment and uncomment code because I don't want the whole thing running all the time. And I want to only just show you segments of how things work. So the first thing I'm going to do is we'll have this worker role fire up, and it's going to populate tables. One of the first things I want to show you, though, is on this side is just the classes here. So you saw the database there for Submarine, and so we have a Submarine class, and in case this is just stupid, simple stuff, right? Just it's a public class. It's using, if anybody's done WCF stuff, you put attributes on it, data contract, data member, to help in serialization, which is needed some places and not needed others, but I'm just going to have it on all of them just to take care of it. And you saw we just have an ID for the Submarine and a name. So real simple here. Since we're going to be working with these Azure tables, there's a new thing that you may not have heard of, and it's called a table service entity. And so it's partly how you work with an Azure table. You fill an entity that has some other things in it besides just the properties, the fields that you want. And you fill that and you save that entity into an Azure table. So in this case, this is it's the same class. It's the Submarine class, except it inherits from table service entity, which means there's some base stuff in there that I'll show you. And again, I'll show you some of that stuff when we're walking through the code, and hopefully I've amped up the font size on these tooltips so that they're viewable. So we've got that. Before we get started, the worker role's got app config. So I need a local connection string to talk to my Azure tables, and a SQL Azure connection string, which, no surprise there, it's just going to my SQL Express database. You will swap those out when you deploy to the cloud, and you'll have cloud versions of that stuff. And you'll have a cloud, a unique key and some other things you use. So it'll be a little bit different. So let's fire this up and start walking through the code. So when I launch Azure, kind of fires up the little Azure emulation environment. Usually will show up on the taskbar. And then it launches the browser. And the browser is, because it thinks, hey, I'm going to call some web services. But we're not going to do that right now. So it launched, and we're right here in the run, which always gets hit first, in the worker role. So we're in our worker role. So let's just get started here. So all this stuff that's commented out, that's kind of the weird code, the different code that you'll use for the cloud version of this. The code I'm going to walk through to initialize local storage is a little bit different. And so, but I wanted to have, and again, I'm going to get all this stuff cleaned up, and I'm going to get this all online so that all of you can have all this code, and then you can go nuts with it. But all I'm doing here when I first fire up the worker role is I'm just initializing, and there's the browser coming along, is initializing all this fun stuff. The account, table, client, there's context, which is used when I'm doing link to it, and stuff with a queue. And I'm not going to use the queue just yet. And so now everything runs in this while loop. This is by default. You can change this. You can spawn threads. You can do a lot of things. I'm just kind of using the out-of-the-box code that you see whenever you have a worker role. So we had to go through the pain of waiting 10 seconds there. And we're just going to step into this. So I created another class, this, SQL to table. What a clever name. To take care of 1 or 1,000 tables to pull over, and each one will work differently. So here I'm passing in table client and service context and things like that. But the key thing, in this area here, and again, this is just personal preference. You could imagine, right? I'm going to walk into this populate Submarine table, but you can imagine having a list of different functions to populate different tables with different filters, and also on different timers. You might not want it happening all the time. So let's step into this. So we're going to make our very familiar looking SQL connection there, and create a connection to SQL Azure. And we're going to just do this stupid simple select ID and name from Submarine and do our reader. And then, so we know that there's stuff in there, which is always a plus for a demo. So now the first thing we do is we're about to loop through our data reader. In the table client code that you have, we're going to delete the table if it exists. So this is a scenario like where maybe you're refreshing it in the middle of the night and you want to just start over. This is the quick and dirty way to do it. You could also try to figure out the changes, and that's a little bit harder. So we're just going to do that for expedience sake. Then the other cool thing here is this create table if not exist. So it takes care of figuring out if something's there or not, and if it's not, it'll just create it for you. So you don't have to detect if it's there and then create it, otherwise not. So now we have a Submarine Azure table created, a shell of it, and then we're going to loop through our data reader. So I talked about the table service entity. So the weird thing there, and we'll point the laser at it, is we're doing this table service contact. We're adding an object. The object, we're going to call the name Submarine. So that's the overall name of the table. And then we're using that table service entity version of the Submarine class. And we have a partition key. And this is the thing. For this case, I'm just going to call it Submarine. But remember, that partition key is the thing where even though it's within the same table, if you change that name, that will dynamically break it apart and run it across multiple servers. So you can, if you need more I/O and need more scale, that's how you do it. Row key, I'm going to use a GUID for this, and this is how you uniquely identify a row, is the partition and a row key. And then in this case, I'm just going to grab the ID, Submarine ID, 1 and 2, and then the name, Seawolf and Nautilus, and set it equal to this table service entity. So we did that. We're just going to loop through a couple times here, and then when we're done, it's not like a normal insert. It's kind of this save changes, and you also have same changes with retries. And so it'll save what you populated into that entity into the table. And so we're all done, and we're going to dispose of that. And we're all finished. And obviously, it's going to keep going here. But we have accomplished our first mission in populating tables. So how do you know? It's like, well, Rob, I don't believe you. Luckily, over here, you've got a viewer to show you what's going on in blobs and tables. It doesn't show you queues. A company called Nudesic has a great tool that you can get on Coplex that lets you, it's an explorer for all the kind of storage. But if I double click on the Azure table, lo and behold, there it is. There's our Submarine, there's the Nautilus and Seawolf. So hey, it worked. Yeehaw. So step 1 of our demo is working, and now we can move along. So this was our demo. So what's the next part? Okay, so now we got stuff on our Azure tables. And now we need to retrieve that data whenever somebody calls our WCF service. We're not going to retrieve it from SQL Azure. We're going to retrieve it from thousands or zillions of Azure tables as needed. And we're going to be able to read that with LINQ. There's a REST interface also to those. And there's a new toolkit out that you may have read about, an Azure toolkit for mobile devices and things that also lets you just talk directly from a device to these. But in this case, this would be part of a bigger architecture where you need to control access to things. And, not that you can't control access with that toolkit, because obviously you have to use a specific key for your device. But in this case, this is just analogous to big systems that you might build. And so people are calling a particular interface through a web service, and then they need to get to those Azure tables. So the key things I'll talk about is and I'm not going to use the device just yet. I'm just going to use the browser, because we're using REST. And so REST means I'm just using the most scalable part of the internet, just HTTP, and you can test it with your browser, which is a beautiful thing. I'll also show you how small the JSON values of the 2 submarines I'm going to get are, and you'll be able to see that in the browser. And then I will also demonstrate, I'll have to try it a few times for the caching to take effect, but I'll show you, I'll let you see for real how this output caching, really works. So let's go back here. So this time we want to make sure that our worker role is not going to start doing anything in the background, because we don't want it to do any work. So let's go back. Let's go out to what we're going to call. So we're doing WCF. So, contract first. So WCF, we're going to create an interface. So I've got a real simple interface here. I've got kind of your out-of-the-box little tester thing. Oh, good point. It's hard to see code without the switch, isn't it? All right. Sorry about that. So this is the interface to our WCF REST services. So in this case, it's iSubService. And so we have our service contract, which is iSubService, and then we have some operational contracts, if you know WCF. And so we're going to use REST instead of SOAP and some other stuff. And so we have to do a few things that are a little bit different. So let's focus a little bit on these operational contracts. you'll see here in this one that I've highlighted, which is kind of just a smoke test thing. There's web get here, and then web invoke. So the difference is if you're using REST principles, if you're doing a GET request, which means I'm getting data, I want to retrieve data, then you'll use web get. But if I'm going to post, put, or delete and use those HTTP verbs, then I will use web invoke. So that's real quick and easy how you know what to use there. Then the next thing is, again, we want to have RESTful URIs. We're not calling into a SOAP black box thing. Everything is just easily findable and navigable and CO friendly on the web. So I create a template. So in this case, the test one up here, I'm just creating a template, get data numbers equal to, and then I put in a value. And we'll do that for a quick test. But down here, getting a list of submarines, I'll just say whack get submarines or whack add a submarine when I'm pushing submarines up there. And so those templates, and either those will map to, this is what's going to be called in the actual service, get submarines, return a list, an observable collection of submarine objects. Or I'm going to send you a particular submarine object and return maybe a true or false. Did it get inserted into the queue? So that's kind of how that works. And then the last thing I want to show you is as we slide across to the right here is how we, the message body, we talk about it being bare. Basically, we want to strip out everything. We want this to be the most lean, mean wire protocol ever. So there's not extra junk, no big SOAP envelope, any of that extra stuff. And then here, both the request and response format, we say message format.json. So we tell it. Now, by default, it's XML. And actually, you can change that to XML there. And so depending on your scenario, you can go either way. And depending on the clients you have to serve, maybe some clients, other platforms that you want to target, other mobile devices, maybe they don't support JSON as easily, and so maybe you need to do XML. The great thing here is we're building something that is based just on the semantics of the internet that anybody can consume, any device can consume. So that's that. So then, after we create an interface, what's the next thing you do with an interface? You implement the interface, don't you? So let's look at our implementation here. Subservice. So this is the guy. I'm going to do walking through a lot of code. Actually, let me go back one quick thing. I did not point out one little thing that you might have noticed. Right here, ASP.NET cache profile. So I've added in references and everything to add in ASP.NET output caching into our WCF REST stuff. It's not kind of there by default. But with this code, you'll see how you can implement it on a service-by-service basis for things that you're getting. And so I'll talk about how you can set a cache. So here, I've set this cache profile for cache submarines, and then that's going to be in the web config. In fact, let's go take a look at the web config real quick. Because caching is your friend, especially for things like submarines. So here's what caching, a little block in the web config you might have. You have a caching block, output caching settings, and then profiles. And so you can create a bunch of different cache profiles that are unique. In this case, I say this one, I just want the cache to last for 60 seconds. But you can make that whatever value you want. It's just using RAM, memory, and everything like that on whatever particular server. And so you could create all kinds of different caches for each of those different tables that you're downloading as appropriate. And I'll show you the difference in performance, obviously, here in a second. Connection strings, right now I've just got the local one just for storage because I don't need it, but you could have your SQL Azure connection strings. You saw that in the app config. The other thing to point out here is the REST behavior. People often say, how do I get REST to work? I can't seem to get REST to work in WCF. You have to create this endpoint behavior. You don't have to call it REST. I just did the name. But the key thing is it's web HTTP versus SOAP. And then down here, the services for the binding, the web HTTP binding, this specifies my service. So that subservice is the actual service being called. The contract is the I subservice that we talked about, and then we implemented that. And then it refers to behavior configuration of REST, which points you back up to here. The last thing I want to point out, so that's how you get restified. Everybody know what being a restafarian is? Okay. The last thing is down here, service hosting environment. Normally you get maybe multiple site bindings equal to true. Add in ASP.NET compatibility enabled equals to true. And the reason for that is that goes back to being able to pull in that ASP.NET caching love that you don't get by default. And then also now when we go to the the service that we're calling itself, we also add in service model activation, and then we had this attribute, this ASP.NET compatibility, requiring that in there on top of that. And that's something else, a little special secret sauce to make that work. Bunch of stuff we don't care about here. It goes back to initializing. We have a constructor when we call the service. But without further ado, let's just run this sucker and walk through some code. So this section, I'm just going to do it quickly all through the browser. So you can just see how easy it is to test stuff and see how restful you are. So let's get a browser up here. No, we don't care about that. So we'll say run. All right. So subservice. We want to test it in our browser. So remember there was that first one that's like get number, just to test to make sure something's working. So I'm going to say get number is equal to 6. And I'm going to hit enter, and boom. It goes right into the debugger and initializes these accounts, storage accounts for the. And then the next thing it's going to do is call into this getData method. It sees that the value is 6. Hopefully you can see that. I've got tooltips cranked up to 16 or 20. Anyway, real simple. I don't want to belabor that one. When it comes back, there's your answer. It came back, you entered 6. So you can see your simple little thing worked. Okay, that's great, Rob. Let's do something real. Let's get a list of submarines. Same list I want to pull back to my device. So get submarines. And I hit enter. All right, we don't want to see the constructor again. That's already getting boring. So let's move along. All right, we're going to call this get submarines method. So you see that my simple REST is calling right into that. So the first thing I do is I'm going to do a link query against table service entities where partition key equals submarine. So I'm just getting everything. I just want to pull down. Anybody ever worked with RDA in the past? Anyway, just give me everything to pull down to the device. So where partition key is equal to sub. Then I'm going to create a list, an observable collection. So you might be saying, why am I not creating a generic list? That just makes more sense. What the heck is an observable collection? Well, it has to do with our love for Silverlight and phones and data binding. That observable collection has some extra events that fire when things changes. So I'm doing this on the server side, and I'll use it on the client side, and it's all because of data binding for Silverlight versus just doing a normal generic. And then I'm going to iterate through this table service entities, and then I'm going to create a new submarine object, and then set the plain old submarine object to equal to what it's finding in the Azure table. And so you can see it's setting the name Nautilus, blah blah blah, and it's going to go through one more time and do the Seawolf. And so real simple. Then it's going to say, oh, we're done. I've iterated through there, and now I'm going to return this observable collection of submarine objects to you. And it came back, and it's here at the bottom, because things are a little different in 99, and it says, hey, there it is. Do you want to open it? And so let's open it. And it looks like we're going to have to open it in Notepad. And it doesn't recognize what it is, because we're not returning XML. We're returning JSON. So here's the JSON format of what it is, ID to named Nautilus. There is no simpler way to return data than this, short of you using a proprietary binary protocol. Nothing will get smaller. And if you combine compression with this, it's just awesome. So anyway, that's how we do it there. OK, so what about caching? We got to make it cache. Seeing is believing. So get submarines. All right, it didn't cache yet because it's calling methods. So I'm going to cancel. Let's try it again. Get submarines. Boom. Did you see that? This time it opened instantly. So it caught into the cache, our little 60-second cache. And so, boom, you got the answer instantaneously. Great user experience. Didn't touch a disk. We increased our performance and scalability. We hate disks. So this is all good. Caching is your friend. All right. Excellent. Now we can move on. I will push the button this time and switch. All right, so now we're going to build on what we've learned about pulling data back, except now we're actually going to do it from a real device and not a browser. And then we're going to do a bunch of stuff that I created myself that's just crazy. I'm going to show you how to pull back this JSON and get it on board the Phone 7. And I'll show you two different ways to get data, because there's web client and HTTP web request. I'll show you both. And then I'll show you how to store that in a structure, a little simple NoSQL database table for submarines that you can query. Luckily, we have links, so I didn't have to create a query engine. That's nice. And I'll show you how to save it to isolated storage and load it so you don't lose it. So it's all good. So let's see how we build that part of the picture. So let's just start by we need to run Azure again because we're going to call it. So we'll just keep that browser will come up after we hit this code here. All right. So we'll minimize that. Now let's go into our Submarine Service phone project. And first thing I want to show you really quick before I run it. Wow, I only have 20 minutes left. Where'd the time go? All right, so let's look inside I've got something called database here. I want to show you that really quick. So this is Rob going on independent ops and rolling my own database. So just use the singleton pattern that there's a few ways to skin that cat, but created a singleton in C# for a database, so there can only be one instance of it. I don't want multiple instances of this object because that would screw things up. I only want one copy, just like you would have one database, right, that you're talking to. I'll walk quickly through some of this code I'm going to call save table and load table. This is easy to use code. You don't have to figure it out yourself now, where you can to save table, you'll just pass in an observable collection of submarine objects. I use the same kind of thing if you came to my session on Monday to build, when I showed how to build a durable message queue, which is crazy fun stuff too. So this will show you how to save the table to isolated storage and using the JSON data contract serializer. So you're going to save it as JSON. Now on Monday, I showed how to do the same thing using the XML serializer. So why should you care either way? The JSON one, you're going, well, Rob, it'll be great. It'll be smaller. It should be faster. The JSON won't take as much room on isolated storage. Well, you're right. But as it turns out, it's slower. And there's some websites where people talk about the different serializers on Phone 7 and how some are faster or slower than others. Some people are into that stuff, you know. And so the XML serializer is a lot faster. It's bigger, but it's faster. And then there's not an out-of-the-box easy binary serializer. You kind of have to write a little extra code, but obviously binary would be even faster. But for small data sets, you won't notice any difference at all. So here's how I'm going to serialize JSON, your list of submarines that way. And again, you can plug anything you want into this, and it'll just work. And then how to load something. So I've got it, and my app is turned off, and I'm launching again, or my device has gone to sleep. And this is how I reload that back into memory so I can start querying it. And then this thing here is a real simple drop table. It's just deleting the file, so no rocket science there. Here's what I'm using to cache to create my kind of in-memory database or table, that I'm going to catch when I'm going to pull back from Azure. I'm going to store it here. So I've got this thing called Submarine table, so it's just an observable collection of submarine objects. And so it's going to live here in memory where I can query it, data bind it, all kinds of stuff. And then here's where I'm kind of going out on a limb. I've just started working on this, so I'll show you a little bit of code. But if you wanted to build your own change tracking engine, and I'm sure there's a lot of different ways to do this, but I've always been accustomed to different sync technologies, and SQL C automatically changes tracking for you. So when I sync again, it uploads just the changes. I'm using a dictionary, and so a lot of change tracking objects systems kind of have an extra table or something that goes along with each table to track what happened, inserts, updates, and deletes. So I'm just, I've only got it working for inserts. So I'll use this dictionary to track changes I make. So let's fire this sucker up. So there's our familiar Submarine Service phone version. You saw the Slate version, and you notice it looks very similar because it has that silly-looking submarine down there. So let's do our little smoke test first. I'm going to call test connection. And so it calls into this text connection method. And I told you I was going to show you two different ways to call REST services from your client, just in case you want to know, because there's subtle differences. This one is using HTTP web request. So you see that familiar URL there, the URI, get data equal number, just when you want to do that simple test. But I'm going to use the HTTP web request in this case. And what that means is that request, if I launch that on a background thread, this will be asynchronous. It'll come back to me on a background thread as well. And I would have to dispatch to get it back onto the UI thread. Later on, I'll show you web client, which is even simpler to use, but it has a different behavior. Sometimes the results will come back on the main thread. Now that will change in Mango, actually. in that behavior. So anyway, I'm going to do a GET request. I'm saying I want to send application JSON, and then here's the callback when the result comes back. And anyway, so I called that asynchronously, but lo and behold, there's something flashing on the bottom of the screen, and it's our Azure subservice. So this is actually working. That's always a plus. And look at that. It actually called our method that we did with the web browser, and now here's the callback. Let's step through it. So now we're back to the other copy of Visual Studio on the client. And so it's calling the callback, and we're going to grab that, and we're going to read to the end the contents, and you can see in the tooltip the big XML you entered. And then to show it, I'm going to use the dispatcher begin invoke in order to show it on the screen. So let's just run, and you hear that telltale sign. And so up there in the message box, it shows back the XML string, because in this case, I'm returning XML and not JSON. All right, so that's cool. So other stuff you would do, this is actually a semi-usable application. There's the passengers. So view submarines. This is where we're going to spend a lot of time. We haven't downloaded any submarines yet, but I'm going to show you how to do all these cool CRUD operations against this NoSQL in-memory database. And then also, if you wanted to make reservations, just like you saw in the Slate app, except we have the cool looking, calendar control that the Slate doesn't have. Anyway. All right, so next thing we need to do is we need to get some data on there. So let's click download. So download, we're calling the get submarines method locally. This time instead I'm going to use the web client, which is a simpler way to call web services. And you can see I'm calling get submarines just like I did from the browser. And then we're off to the races. And then luckily, this is working. Azure sub is calling, and there it is. It's on the Azure side. It's calling. It says get submarines. And just like we did from the browser, we're going to use a link query against Azure tables and pull back that, create a list of observable collection of submarine objects. We've seen this before, so I'm going to hit run to get through it. And now we're back to the device on the callback. And so this time, use the data contract JSON serializer, because we're sending over JSON, to catch the data coming at you. And then we deserialize it. And so there, that database.instance.submarines, that's our in-memory table that I showed you. And that's how you use the instance deal. So let's prove that something came in there. So I'm going to do the tooltip there. And it's going to make us drill in way too far. But there's the count. It's showing 2 items in there. So I'm getting a warm fuzzy there. And here are the items, Nautilus and Seawolf. So we know that we've successfully pulled the Nautilus and Seawolf onto our phone. So we're really happy about that. So let's go to View Submarines and click View. All right. So here we're going to just do a simple data binding. I'm going to bind a list box, Silverlight list box, directly to the in-memory table. And all I have to do is to say, yeah, I want to display the name part of that object, and then set the item source. So nothing too fancy there. And sure enough, there's Seawolf and Nautilus. Well, what if I needed to leave the app right now? So I told you we have stuff to serialize it. So I'm going to save it. And for time's sake, I'm not going to drill into all the code on that save table that I showed you earlier. But it didn't throw an exception, so it must have worked. So we just saved that. So now I'm going to hit back. And we're just going to exit the app. Because again, I'm a show me state kind of guy. Seeing is believing. You need to believe that that data is really saved. Because I don't want to have to pull it down again. I've already gotten it. So passengers, view submarines. Now let's hit load. And we're going to step through there. And it's going to load that from isolated storage. We're highlighting submarines. Did something make it in there? Yep, there's our count of 2. So we got our data back from isolated storage. So I don't have to call the web service again because I've already got it locally. So I'm doing disconnected offline stuff, which every device has to be able to do because sometimes I have wireless connectivity, but if I walk over here, it's all gone, right? So no such thing as ubiquitous wireless. And so you have to plan for that and develop for that. All right, so view. Don't need to debug that again. We know how view works. It's already showing us Seawolf and Nautilus. All right. So let's do some manipulations to that. I'm going to, let's see here. First I'll do a link query. It's not a complex link query, but I'll show you how you could use link to fill that data right from the same thing. So instead of data binding directly against that, I'm just going to use a link query. And in this case, it's just stupid simple. I'm saying we're submarine ID equals 1. Same kind of code here at the bottom. And you'll see that now it's just showing Seawolf, because that's all I asked for. All right, cool. Let's go back to view again. Now I'll see everything. Now, let's see. I'm going to update the Nautilus here. So I'm going to run update against that. I've got some hard-coded stuff. I'm going to name it a different name of a different submarine that I served on way back when, called the John Marshall. Now, the John Marshall used to be a Supreme Court justice way back when. All right. Now I might want to delete John Marshall and say, sorry, we're decommissioning your submarine because it's too old, and now he's gone. So that's good. I can also say load again because I want all my data back again, and hit view, and now I've got everybody back. Now let's do an add. I'm going to add the last submarine I served on, which was a Trident submarine. It was called the Alaska. And so we step through that, and we add the Alaska. Now along the way, I used the submarine changes.add, my little change tracking engine dictionary, and added, change tracking engines usually were based on primary keys, and then what was the operation, insert, update, delete. So real simplified. I'm sure there's other ways to do it. So primary key of the submarine, and in this case, I just said I for insert. So we did change tracking. We got all this guy on here. So we're good to go. So let's now go back. We can move on to the next segment because we have 9 minutes left. It's a countdown before it explodes. All right. No. All right. So we manipulated the heck out of the data here. You saw a local database, NoSQL. You saw change tracking. Now we added something. We added the Alaska. So I need the Alaska to get back into SQL Azure, but I'm not going to call him directly. I'm going to call my web service, and he's going to insert it into an Azure queue. Immediately, we're going to have a loosely coupled system. Grab this, drop it into the queue, and you're gone. And then, and so we're going to do that first here. So let's do that real quick. So let's call the upload method. And here's where it's a little differently. Before I call the web client stuff, you get to see this change tracking engine in all its glory. I'm just enumerating the changes, and so I'm going to iterate through there until I found which one had changed, where the key value equal to I, and I found it, and then using the link query based on that result that I got back from enumerating the change tracking engine, and grabbed what was the first submarine, and there it is. It's ID 4. There's the Alaska. Now we're going to serialize that submarine as JSON because I care about wireless being efficient, and I'm going to use the web client. And this is how you upload data back to Azure. And I'm going to call the add submarine URI that you saw us create in that Azure interface before. And this guy's going to finish. He knows there's nobody else to enumerate. And then boom, we're already over in the Azure side of Visual Studio. So we jumped over there. It's great that we can have all these versions. So prove that the object made it successfully. Yep, there's the Alaska. He's now there at the web service. But I need to serialize it. I'm going to drop it in the queue. The queue understands like XML or binary, Azure queues. So I need to turn this back into XML again. So I'm going to call into this little, I'm going to use the data contract serializer here, and I'm going to serialize this guy to XML. And so now you see this XML version of that object. Then I'm going to create a queue, and we're going to get a reference to something called a queue we've created. You can create as many queues as you want on the fly. This one's called add submarine, create if not exist, kind of like you saw with Azure tables. Then I'm going to create this new message using that string, and I'm going to add the message, and it went successfully, so it dropped that into the queue, and then we're returning true, and then boom, we just flew back to the other instance of Visual Studio where we have the callback. And luckily, the callback is true. So we're feeling the love, and now our client knows that our message has been received, and it's dropped into the queue, so we're all cool. We're loosely coupled, and we're not holding up anything. We're not blocking. So we're done with that. Let's see here. We can close down the emulator now because we're not doing anything more on the client. Everything is on Azure. So one thing I need to do real quick is I got to close Azure, And we'll get to, and I'm going to do, I told you from time to time I would have to comment out code to make sure things worked properly in different parts. That's why I have all this, my little script here with me to make sure I do the right stuff. So, worker role, I'm going to uncomment the part where it pulls from the queue. So, this is the last part. I'm going to pull stuff from the queues with a worker role. Kind of just, in this case, it'll be just as simple as you saw when we populated Azure tables. I'm going to pull from queues. And again, you could have hundreds of queues or thousands of queues for uploading all kinds of different things. And you could have multiple instances of worker roles that are rapidly pulling things from queues. So I'm just trying to keep it simple for you, just using one thing so we don't get too confused. But I don't want you to think that you're constrained in scale in any way. You can go nuts with this. So all we're going to show here, pull from the queue, insert to SQL Azure, and our whole round trip will be complete. And you'll see how the whole system has worked. So this time, we'll fire up Azure again. And our browser will come up, but we're not going to use it. We're going to just go run here. So remember, this is how you begin our worker role. And oh gosh, we got to count to 10. So we'll minimize this. This guy is sleeping for 10 seconds, and then we're going to jump in here. We're going to call my little inbox. So we'll step into this. So read queues method. We're passing along references to the Azure connection string, as well as the queue client. And then here, add submarine, just analogous to like when you saw me populating Azure tables. You could have as many of these depending on how many queues you had and how many tables you need to update in SQL Azure. So let's go to add submarine. We're going to do the same code you just saw before. Get a reference to add submarine. Create if not exist. Luckily, it exists. We say, then we grab the current message from it. And if current message is not equal to null, we double check. Then we do this message as string. It could be as binary, but so we're going to stringify. And so again, there's that familiar XML string that we turn the object into. If it's not empty, then we're going to deserialize that object. So I'm going to use the reverse. You saw me serialize it before with the data contract serializer. Now I'm going to deserialize it. And lo and behold, we have our original Alaska object. So this is really working. You got to love that. It's not equal to null. Create our connection to SQL Azure. Open the connection. Do a simple insert. There's our stuff. Execute non-query. Dispose of the command. And then since that executed properly, then we know we are safe to delete the message from the queue because now we're in the database table. And so we do that, and we're all done. Yay, it actually worked. You gotta love it. So we made a whole round trip through the entire system. I'm going to give it to you. But it's not on ComNet or whatever we call it yet. So I'm going to give you cards. I'm going to take everything I showed you, kind of like I did last year and in Europe. I'm going to start doing a series of blog posts on robtiffany.com where I will blog about and I might go into more depth because I'll have more time into each segment of this. And so here's the done part. We've completed the progress bar. And so there's the whole giant thing. It was real simple here, but the simple principles expanded out to the nth degree is how you will build a ridiculously scalable system. So if you're lucky enough to build the next hot thing that 1 million people want to use, this is how you're going to do it. You're probably not going to host it on GoDaddy or something like that. That might not work. I don't know. So that's it. So what's our takeaways? I tried to hit home at the beginning that even though things seem like they're getting better in wireless with technology, we also have things working against us. There's lots of congestion, and it's on you. You cannot defer user experience and say, well, it's the network's fault. You need to take ownership. And so say, nope, I don't care about the slow network. I'm going to target GPRS. I'm going to say my app's designed to succeed at 28.8 speeds. And then I'm going to cache offline because I'm not going to say, oh, well, you're not connected to the internet, so you don't work anymore. Wrong answer. People have got to keep working when they're offline. It's all about that. Then we talked about internet scale, lots of examples from the biggest scalable systems, and then how we can map that to yourselves. Definitely come hang out at robtiffany.com. I blog all the time. I'm going to blog about everything you saw here in greater depth. I'll have a whole series of articles going throughout the summer. I'll have all the code. I'm also, if you came to my Monday session, using some of the similar principles. I'm going to show you how to build a reliable message queue, and I'm going to blog about that, how to build queuing system, because sometimes you need a queuing system to complement pulling down big data. And this queuing system can do pseudo peer-to-peer. You can call to other devices and all kinds of things. To get started with all this stuff, like particularly with the Visual Studio stuff you saw here on the device, go to create.msdn.com. That's how you get started with doing Phone 7 stuff. And you can get the tools, tutorials, videos. It's all free. It's all good. Hopefully you have what you need. I'm so glad you came. Now, here's the really important part. Somebody's going to get a phone. I'm going to ask a question, but I don't want people to blurt it out because that's what always happens. I'm going to ask the question, and you're going to raise your hand, and I will call on you. If you blurt it out, you'll be disqualified. What type of object did I use to do change tracking? Yes, you, sir. Dictionary. You get the phone. All right. Woo! Thank you so much for coming. Try to remember to do your evaluations, and have a great rest of the show.